Now let's examine this resource allocation graph. So sometimes resource allocation graph is going to be useful. So till now we have been using some kind of tables like allocated and then request and then available, all that things to understand what is the state of a system. Similarly, if you want to understand the state of a system, instead of using those tables, actually tables are very easy to represent and understand it, but then still you could even represent the same information using the graphs, and that graph is called as resource allocation graph. So resource allocation graph will explain us what is the state of a system in terms of processes and resources, like how many resources are available, how many are allocated, and what is the request of each, future request of each process. Everything can be represented in terms of a diagram. And one advantage of having a diagram is maybe sometimes it is possible to see a deadlock directly by looking at the resource allocation graph, but then you might not be able to know that by looking at the tables that we have given, right? Resource allocation table and all, right? That matrix and all this, the numbers, sometimes diagrams have more easy and intuitive and even easy to understand the diagrams compared to the numbers if they are given in a matrix. That is the only advantage. And anyway, as the system contains lots of process and lots of resources, representing it in terms of a graph and understanding it is going to be complex. So tables are better if the system contains lots of resources and process, and graph is better if the system contains less number of resources and process. So now just understand the graph here. So any graph as will contain vertices and edges, right? So resource allocation graph also contains vertices and edges. So vertices are of two types. Every process will be represented as a process vertex, and every resource will be represented as a resource vertex. Generally process will be represented with a circle. And resources are generally of two types. One is single instance resource and other is multi-instance resource. If you have only one CPU, then that is single instance resource, right? Therefore, single instance resource is going to be represented as a box inside which there is only one dot. So the number of dots indicate how many instances are present of each resource type. So here of this resource type is containing only one instance, right? And here this resource type contains 4 instances, right? Because it is register. And coming to edges, there are two types of edges. One is assign edge and other is request edge. Assign edge means if you have already assigned a register to a process, then it is called, a resource to a process, then it is called as assignment, right? So this edge, which is starting from this resource to the process, will indicate that one instance of this resource is allocated to the process PI. And other thing is request edge. Request edge means in future the process might want this resource to complete its execution. That is called as request edge. So request edge will say that from here, for this process it requires one instance of Ri. Got it? And in terms of multi-instance resources, you can even write like this. If you have 2 instances, then you can say that 2 instances are allocated to process like this, right? So anyway, this is the resource allocation graph. Now let's examine various types of graphs and how to convert the given a graph information. You should be able to convert it into the tables like allocation table and request table, and then you should be able to find out the state. So generally, given a graph, you should be able to say what is the state of it. Either is it safe, or is it in deadlock, or is it in unsafe state, right? Let's see that.